Thank you for joining us. My name is Burak, along with my colleague Göktuğ. We are excited to share our journey at Trendyol. Today, we are going to talk about how we handled the growing complexity of our data orchestration environment. We'll walk you through our evolution from an on-prem setup to a unified hybrid cloud platform we built called TaskHarbor. This is our story of moving from complexity to simplicity. To guide through our journey today, we have structured our talk into four main parts. First, we'll start with the problem. We'll briefly talk about our starting point at Trendyol, the challenge we faced with our old setup and why we needed a change. Next, we'll move into the solution. This is where we'll introduce TaskHarbor and walk you through the hybrid architecture. Then we'll do a technical deep dive into the core components that make TaskHarbor work. We'll look at how we use Google Cloud Platform features for security and connectivity. And we'll show you how our auto-deployer system automates both infrastructure and Airflow deployment. Finally, we'll share the results, showing the impact of this platform had on our operations. So, let's get started. For those of you who may not be familiar with us, Trendyol is one of the leading e-commerce platforms in our region, operating at a massive scale with millions of daily active users and terabytes of data generated every day. For us, reliable data pipelines aren't just a technical requirement. They are a core business necessity. It powers our recommendation engines, our marketing strategies, our logistics, and much more. So, how we use Airflow at Trendyol? Airflow is a critical tool and widely adopted by many teams. Our central Airflow team were running more than 10 separate on-prem Airflow instances, each tailored to different needs. Also, this setup was a mix of virtual machines and internal Kubernetes clusters. In the beginning, this model worked well. It gave teams the speed they needed to build their own workflows. However, as Trendyol grew, the problems with this approach started to arise. The operational overhead of managing, maintaining, and securing numerous different environments became a major challenge for our central Airflow team. So we decided to make a change. Let's talk about the challenges we faced. First, the maintenance overhead was huge. Manually managing PostgreSQL databases for each instance was resource intensive. Furthermore, our internal clusters lacked not auto-scaling. This meant we were constantly need scaling during peak times, and we were wasting idle resources during off-peak times. Our monitoring solutions were simply less effective than modern, for example, cloud-native tools. This limited our visibility and made troubleshooting a nightmare. Deployments were another major pain point. Imagine trying to roll out a critical patch or a new Airflow version. Doing this across several distributed instances was a slow, manual, and incredibly error-prone process. Finally, security and access control were becoming unmanageable. Granting permissions and ensuring secure connectivity was a significant problem. It was clear that our existing setup couldn't support our load. To solve these problems, we began exploring cloud-based solutions. Our first consideration was Google Cloud Composer. It promised simplified management and deep integration with the Google Cloud ecosystem. We conducted extensive tests, and while Composer worked well for many cases, we found its customization options were limited and monitoring was difficult because we couldn't directly access the underlying databases. Also, Most importantly, we had concerns about its ability to scale to our needs, as it struggled with a large number of concurrent tasks. Our second option was deploying Airflow directly on Google Kubernetes engine. This approach gave us everything we wanted in terms of control, customization, and cost effectiveness at scale. But it presented a new critical problem we called the hybrid challenge, which translates into a question. How could our task running on cloud access data sources in on-prem data centers? Neither of these solutions was the perfect fit. We needed the best of both worlds. Now, I will hand the floor over to Göktuğ. He will talk us through TaskHarbor's architecture and detail how it addresses our specific pain points.
Thank you. Hello, everyone. First of all, thanks for the introduction, Burak. As you mentioned, the complexity we were facing required something new. That's why we designed our own solution, a hybrid architecture we named TaskHarbor. This platform combines the power and scalability of cloud with the on-premises execution. So let's walk you through the architecture. The core of our system is Airflow running on GKE. And this gives us the control and scalability we needed. For the backend, we use managed cloud services, CloudSQL for the metadata and result backend databases, and memory store for Redis. This eliminates the database maintenance overhead we had on-prem. But the real key to this infrastructure is the flexible execution layer. We designed the system so that tasks can be executed by different types of workers. We have workers running on GKE for cloud-native tasks, and crucially, workers that run on our own infrastructure. These on-prem workers integrate Airflow on the cloud, but execute securely within our data centers. Another key piece of our technical design was simplifying the DAG management. In our old setup, teams might need to store their DAGs in different Git repositories. Trying to sync all of these using a tool like GitSync would have been a problem. Instead, we created a simple, more centralized model. We have a designated GCS bucket for each Airflow instance to act as a single source of truth for the DAGs. We then use the GCS Fuse, which mounts that cloud storage bucket directly into the Airflow scheduler and the worker pods as if it's a local folder. This completely decouples DAG deployment from the Airflow application deployment, making the entire process much cleaner. You can see a real-life scenario in the screen. So we have a team consist of multiple subdomains, and they all use different Git repositories. So we share them a GitLab CI/CD template to push their DAGs into GCS bucket as well as the Airflow. So it's a very easy process for us. Now let's talk about the connectivity and security. So we use HTTPS load balancers with network endpoint groups to expose our Airflow web servers to on-premises network along with a DNS assignment. We have previously experienced that managing user credentials across different Airflow instances with basic authentication was a significant security risk. To solve this, we use Google Authentication and placed our Airflow web server behind the Google Identity-Aware proxy you can see on the screen. Think this as a smart and central security guard for our application. Before a user can even reach the Airflow login screen, they must first authenticate with their corporate Google account and verify that he or she is authorized to access that Airflow instance. This gave us a robust single sign-on capabilities and allow us to manage access centrally through standard Google Cloud IAM policies. Now for the biggest technical problem, the hybrid connection. How do our on-premise workers securely talk to our new CloudSQL databases in GCP? We could not, of course, expose our database to public internet, so the solution was a specific networking tool, which is internal pass-through load balancer. Here's how it works. So we run a PG bouncer service in the Google Kubernetes engine to manage database connections efficiently. The TCP load balancer gives this PG bouncer service an internal IP address which is only reachable from our on-premise data centers via our secure interconnect. And this means our on-prem workers can connect directly and securely to the database in the cloud without compromising the database itself. And this piece of networking made our entire hybrid execution model possible and combines security with high performance. So the big question is, how do we bring all of these components of the platform together and manage deployments? It all starts with our auto-deployer pipeline, which is our internal CI/CD system designed to abstract away all of the complexity. We want to take the automation one step further and simplify the experience for everyone. So this diagram shows how it works and will be discussed in the following slides. Our first step is the configuration and approval step. So a platform admin provides a simple configuration file in a merge request, which includes the metadata information like team name and the resources they need, and also additional custom configurations. Once this merge request is reviewed and approved, the GitLab pipeline triggers after merge. So let's first look at how we handle the infrastructure part. The goal was to eliminate manual and complex setup entirely. We actually didn't want our teams to write Terraform code or clicking around in the Google Cloud Console. When this merge is initiated, it triggers the first stage of our GitLab pipeline. And this stage is powered entirely by Terraform. The pipeline reads that YAML, which you can see on the screen, and translates it into Terraform variables, and automatically provisions everything for the new Airflow instance. And the provisioning part includes all of the necessary artifacts, such as the G-key cluster, namespaces, secrets, and service accounts. Also, CloudSQL instances for metadata and backend databases are also created. Google Cloud Storage for logs and DAG management also created, and IAM bindings for authorization is provided. By treating our infrastructure as a code, we guarantee that every single deployment is consistent, repeatable, and simple. Once our infrastructure is ready, the second stage of the auto-deploy pipeline kicks in to handle the Airflow application deployment itself. One of the biggest challenges with deploying Airflow on Kubernetes is the official Helm chart, actually. Even though it's incredibly powerful and handles everything, it's also over 2,500 lines long, so it's very complicated, and asking every team member to master this file wasn't a proper solution. So our auto-deployer solved this problem as acting as an intelligent configuration generator. It automatically generates the complex values YAML file needed by Helm. And the pipeline processes user-provided config to, first of all, build a new Docker image if any custom dependencies are specified. Then deploys all of the core Airflow components and load balancers into correct G-key and cluster and namespaces. And simultaneously, it generates and pushes necessary configuration files for the on-premise workers. This process completely decouples the application from the infrastructure and transforms a highly complex deployment into a simple and declarative process. For our users, the entire experience is reduced to editing easy-to-understand configuration files. Another key problem of our old system was monitoring. It was a collection of custom tools and terminal commands, sadly, that gave us very limited insight. But with TaskHarbor, we made comprehensive monitoring possible. By running our platform on GCP, we gained the ability to use powerful native cloud tools. We now use cloud logging to capture and centralize all of our logs from core components of the system. This gives us one place to go for troubleshooting. For instant visualization and real-time insights, we use Grafana because we have direct access to underlying databases, which can't be done with the Cloud Composer, actually. We can build rich, detailed dashboards and alerts for our customers. As you can see on the screen with the sample dashboard, we can track everything from DAG counts, running task durations, queue task durations, etc. We can also generate alerts based on these metrics, and this allows us to give DAG and task level insights for our users. So after all of this that I've mentioned, what's been the impact of the TaskHarbor? First of all, our management went from complex and manual to simplified. Secondly, scalability is no longer a concern. We can now auto-scale our resources based on demand. Also, our costs are optimized because we can choose the most efficient execution environment. Also, our monitoring is now comprehensive and centralized, giving us deep insights into every workflow. Another one is deployments that used to need manual work are now fast and repeatable. Also, they are fully automated. And our security is more robust than ever with the centralized access control management. And we have fundamentally changed how our teams interact with Airflow and led them to focus on building data pipelines, not managing the whole infrastructure. To show you what this means for our teams, let's look at our data science department. They were struggling with a monolithic Airflow instance, which resides in an old virtual machine and that could not be able to scale. During critical campaign periods, it would fail and cause a lot of problems for everyone involved. Also, updates and security patches were high risk, and so their system is outdated. With TaskHarbor, we moved them to a modern platform. Now they pipelines auto-scale effortlessly during peak loads, and maintenance is automated and handled by the platform also. So what's the result? The result is our data scientists can now focus entirely on their work without worrying about the scheduling problems. And our central Airflow team is free from constant support needs. And this transformed the entire workflow from high risk to high efficiency. So to wrap up, I want to underline three key takeaways from our journey. First of all, TaskHarbor truly represents a move from complexity to simplicity by building a robust automated platform. And we have enabled our teams to move faster and more quickly. And second, for an organization like ours with a lot of on-premise dependencies, a hybrid architecture was a truly good answer. It allowed us to leverage the best of the cloud without leaving our existing systems behind. And finally, the investment we made in building TaskHarbor has paid for itself in many times over efficiency, reliability, and speed. Thank you all very much for your time and attention. We hope our story has been insightful.